Hello, welcome back to another discussion. Today we're gonna discuss about sorting algorithm. Have you ever noticed every time you have flag ceremonies in your school, every time you fall in line in a canteen, but in reality it's all crowded and disordered, every time it's recess because students at your school compete with one another to buy food. Or have you ever see a line of cars in traffic jam waiting for the green light while a driver picking their nose inside the car and act like they didn't after their wife saw them excavating boogers? These are all lists or arrays. These are all like example of a list or arrays. It can be disordered or disarrayed, but it's still an array. By using sorting algorithm, we can arrange this array by color, age, or we can arrange those I mentioned earlier by color, age, height, size. And for example, in your flag ceremonies, you can arrange by height or we can arrange by size. And in data structure, we have sorting algorithms. In World Wide Web, we have uh, also to utilize sorting algorithm, and it's considered important because of the overload, continuous uploading and downloading of data. Programmers must have a way to sort all of this, and we don't want all of our data to be disorganized. So we sort files and data in order to control and manipulate it easier. And we can also search data much faster. And in the world of technology advancement, sorting algorithm plays an important role in data structure programming. And from banks to companies to NASA to computer research, we have sorting algorithms. In the next slides, we're going to discuss about different types of sorting algorithms and how to do it. So after all that I explained, how, I hope you have an idea of what sorting algorithm is all about. So here I have a textbook definition of sorting algorithm. An algorithm that puts element in a list on ascending or descending order. It's easy to understand this, but there are quite a few things to consider in sorting algorithm. Time complexity and choosing the best sort method to apply on a specific coding project. And this we have the term comparison operator on the elements. Comparison operator is used to decide the new order of element in the respective data structure. And we have here the different types. As I mentioned, we have bubble sort, selection sort, insertion sort, shell sort, merge sort, and heap sort. Um, Next, first we're gonna discuss about the bubble sort. Bubble sort is the simplest sorting algorithm that works by repeated swapping of close pairs element in a list if they are in a wrong order. Here, this is the first uh, pass. First off, here I have a pseudocode of the bubble sort. Let So our A is an array of numbers. Let us say the numbers 2, 10, 5, 9, 13, 6. So the length of those are 6. So in the pseudocode, we're gonna initialize temp j to integers, and we have a for loop, nested for loop for to be specific. Um, for this is the loop variable for int I. So length of the array minus 1, and we have a condition if I is greater than 0, it's gonna for loop. and we're gonna decrement in the value I. So we have another for loop where is the looping of the elements and the swapping. So here we have int j is equals to 0 initialized. So our condition is j is less than I, and we're gonna increment. So for example, and all of that if statement is gonna swap, or if the if statement is not satisfied, so it's just gonna go continue in the for loop until the end. Here our first for loop, here we have 2 and 10, the first close pair, and or the indices 0 and 1. So 2 is less than 10, so 2 is greater. So we put here in the if statement 2 is greater than 10. So that is false. So it won't swap. Next, we're gonna add up. So I'm gonna increment j here. So it's gonna be 2 and 1. Here, 5. So the indices 2 and 1 is index 2 is 5, index 1 is 10. So here we have index, so 10 is greater than 5, so it's gonna swap. Next, we have 10 is greater than 9, so it's gonna swap again. And 10 is 10 greater than 13? No, 10 is not greater than 13, so it won't swap. And here 13 is greater than 6. Oh, I didn't change it. This is supposed to be let me fix that. Marker pala. Marker. 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 Yan. Hala. Bakit ganun? Basta, yeah, it will swap here. Just erase this. So this is the first pass. And it's gonna continue with the loop variable. We still have, so here in this loop variable here, int I, so it's equals to 6 minus 1 is equals to 5, so maging 4 na lang. So 4 is greater than 0. So continue, there is a second pass. I-compare naman, so 2 will be out of the question, out of the loop. 2 will be out of the process, so it's gonna be 5. 5 is less than 9. It's gonna swap. It won't swap. My bad. It won't swap. And we have 9. 9 is less than 10, so it won't swap. So next one is 10 is greater than 6, so it will swap. And 10 is less than 13, so that is the second pass. And 13, wala na siyang katabi, so ma-end ng for loop and ma-continue sa loop variable. So sa ikatatlo na, sa 9 na tayo. So 9 is greater than 6, so Mali naman lagay ko. So it will swap. So magsa-swap yan. So 9 is less than 10, it won't swap. And 10 is less than 13, it won't swap. So this is the third pass. And the fourth pass, mag-e-end ang loop dito kasi wala nang katabi ang 13. So so our I equivalent now is 3. So sa 9 is less than 10. So it won't swap. So 10 is less than 13, so it won't swap naman. So hanggang labas na sa loop variable na ito. So that will be the output of our bubble sort. Ito na yung output. So that is bubble sort, and this is the pseudocode. So that is a simple sorting algorithm. Next we're gonna wait. So a bubble sort is slow, and because the algorithm traverses a list and compares adjacent values, so it takes time swapping them if they are not in the correct order, with the worst case time complexity of big O n raised to 2. And bubble sort is very slow compared to other sorting algorithms like quicksort. Next, we're gonna move on. I didn't turn off. Selection sort. Selection sort finds the minimum value in an array and place it in front, incrementing the index 1 and finding the incrementing the index by 1 and finding the minimum value. So we have here 13 numbers in the array, numbers 13, 7, 8, 2, 5, 55, 12. So find the smallest number. So here the smallest number is 2. We're gonna swap 2 to 13. So next we have here, we already swap it, 2, 7, 8, 13, 55, and 12. From index 1 to 5, find the smallest number. So what is the smallest number? That is 7. And next, we're gonna find, so 7 is already in this index 1, so it won't swap. So from index 2 to 5, find the smallest number. So 8. So 8 is on the index 2 now, so it won't swap now. So from index 3 to 5, we're gonna find the smallest number, which is 12. So we're gonna swap it. Swap 12 to 13. So from here we have 2, 7, 8, 12, 55, 13. So last, from index 4 and 5, we have 55 and 13. So 13 is the smallest number. We're gonna swap 13 to 55. So 2. So we have the output of 2, 7, 8, 12, 13, 55 with the selection sort, using the selection sort. So selection sort can be good at checking if everything is already sorted. It is also good to use when memory space is limited, and so selection sort doesn't go around swapping things until the very end. So sinaswap niya lang kung kinakailangan. Hindi niya na traverse ang whole paulit-ulit compared to bubble sort. So moving on, we have the insertion sort. a simple type of sorting algorithm. We increment 1 starting from index 1. Increment 1. So, mean to say, sinusort um, from smallest to largest number. So, we increment 1 starting from index 1, and the data of the chosen index is compared to the data of the index to the left. Indices to the left. Index or indices to the left. And if the value is less than of the right index, it will swap. If the value is less than of the current index that is traversing the whole array, it will swap places under there until there is no index left, and if the chosen index is greater than the right index. So we have here the array 10, 6, 4, 7, 12, 9, 2, 11. So starting from index 1, we're gonna swap to the left. Parang ginagawang by ascending order. So ang unang value is 6. So 6 swap mo sa 10. So 6 is less than 10. So mag-swap sila. And increment yan by 1. So we have the index 2. So index 2 is, the value is 4. So ang 4 magsaswap sa 10. So 4 is less than 10, so swap sila. And 4 is less than 6, so magsaswap. So ang first index value natin is 4. So we increment another one. 1. Ayan pala, this is the pseudocode for the insertion sort. So we have 7, magsaswap sa 10. 7 dito magsaswap sa 6 kasi 7 is greater than 6. And next, we increment another one. 12. So 12 is greater than 10. So di tayo magsaswap. Next is 9. 9 is less than 12, so we're gonna swap places with 12. 9 is less than 10, so magsaswap sila. And that is also the same. The process will go on the same with 2 and 11. And we have the output of 2, 4. We have already the sorted output of the array 2, 4, 6, 7, 9, 10, 11, 12. And here is the pseudocode. Like the same, let A be an array of numbers. So we can initialize I and J. And here we have, so this is also a nested loop for, it's also the same with, but differs in, it's also the same with bubble but differs in yes, ang sinaswap. So insertion sort can be a good thing if the input of the, for example, input array is already nearly sorted. It can fairly fast running, mabilis ang pag-sort kasi stable. Ayan lang. Wait. And it can use mga simple na computer programs such as file search, data compression, and pathfinding. So next, we're gonna move on with the next sort. We have the shell sort. Shell sort is a highly efficient sorting algorithm and is based on insertion sort program. This algorithm avoids large shifts as in case of insertion sort if the smaller value is to the far right and has to be moved to the far left. So shell sort is good for um, so by simply saying shell sort is an optimized version of insertion sort that allows the exchange of items that are far apart. And the idea of shell sort is to arrange the list of elements so that starting anywhere, taking every element, produce a sorted list. So here we have a list or an array 20, 20, 13, 10, 7, 43, 22. So we're gonna, for example, we're gonna take intervals of 3. So we're gonna pair them 20 with 7, 13 with 43, 10 with 22. And we swap the values from minimum to maximum. And here we have 7. So 20 and 7 we're gonna swap, maging 7, comma 20. And the rest from Dina. So the final output of the first is 7, 13, 10, 20, 43, 22. So we're gonna compare and swap. Um, we're gonna we're gonna take the intervals of 1. So here we have 7, 10, 43. We compare and swap the values in the original if required. So in this case, hindi na. So here we're gonna um, proceed with the insertion sort. So I already tackled insertion sort. The process is getting an index and um, moving it to the left side if it is less than the value of that of the left side. Move on, we have the merge sort. Merge sort is a divide and conquer algorithm, meaning to say it divides the output into two halves, call itself for the two halves, and merges the two sorted halves. So when it divides until the size is 1. So here the size is sorry. So here the size is 1. We have 22, 13, 56, 4. So after that, we're going to merge one by one. So starting here, we're gonna start from the left. This is like a binary tree. We're gonna start from the left sub tree. So 22, 13, 56, 4. So after that, we're gonna move to 22 and 13. This is going to separate both and going to merge it again. We have 13, 22. Next next level is going to be 56 and 4. So it's gonna divide that again, 56, 4, and sort it 4 and 56. And I forgot an arrow here. It's supposed to be an arrow there. So there's supposed to be an arrow here connecting to the sorted list here. 4, 13, 22, 56. Next is we're gonna go with the right subtree, 23, 6, 12, 18. So next first is gonna go with 23 and 16. So you're gonna divide that. You're gonna sort it. So we have 6 and 23. And next is we're gonna go with 12 and 18. We're gonna divide that. So still 12 and 18. Next is going to merge them and sort them in a list. And after that, we're gonna sort this and this, so it will have a sorted output, which is 4, 6, 12, 13, 18, 22, 23, 56. So uh, moving on, we have the heap sort. As the name suggests, we're going to make a heap using the given elements in the array. First, create a max heap to sort the elements in ascending order. We swap the root node with the last node and delete the last node from the heap. So here we have a list. We have an array 7 2, or an array we have a 7 2 3 9 6. So we're going to make a heap, create a heap 7 2 3 9 6. So we're going to we're going to search for the max heap. So the max heap here is 9. So we're going to swap 7 with 9. And we have here 2. 2 is greater than 7. 2 is less than 7, I mean. So we're going to swap that. It's going to go down here. Here we have 2. Next is 2 is less than 6. So we're going to swap that too. Now here is the value 2. And lastly, as indicated at the top, the first node is swapped with the last node. So the value 9 here, we're going to swap that with 2 here. So we have 2 7 3 6 9. So the last node here, we're going to delete that, and we have 2 7 3 6. So we're going to repeat the process. We're going to locate the max heap. In the max heap, we have 7. We're going to 2 is less than 6. We're going to swap that. So we have the last node 2, and we're going to swap that with the first node. So 7 is out. Next, here we have 26379. 263, the max heap is 6. So we're going to, oh my gosh, what's this? All these ads. We have where am I? Okay, we have 2. We already swapped. So 2, we must put it on the right node. So because it's less than 3, so we have here 3. We have 2 here on the last node. I'm gonna swap that with the first node, so 6 is already out. 6 is out now. So we have here 2. We're gonna swap that with 3, and then gonna swap again. So we already have our sorted list. 2 3 6 7 9. So that is the heap sort. So I have a question. Why do we need sorting algorithms? What state you can state the importance and the purpose and the goal of sorting algorithm. And here is a personal question. What is your personal favorite sorting algorithm and why?